Hi guys, I'm Kalawa, and this is Main Simple Resource. Don't forget to subscribe to our channel and always hit the notification button so you'll be first to know whenever we publish video like this. Let's understand the multiplication of matrix by a scalar and that of a vector. First, let's understand a scalar matrix. How do we multiply a scalar matrix? To multiply a matrix by a number that is a scalar, multiply each element of the matrix by the number. Okay, so they are saying, let's say we have a constant in front of a matrix. For example, let's say we are given 2A matrix, and then they say and then they give us A element to B. I just use letter A, B, C, D, which is the A element. But remember, we have 2 here in front of the A. So meaning they are saying if we have a number outside the element of the matrix, that number or that constant, we call it as a scalar. So that type of matrix is known as a scalar matrix. So in other words, they are saying that we are going to multiply this scalar or the number by each of the elements in the matrix, by each of the elements. So this is now going to be 2 into A, B, C, D. So this is going to set the matrix. So this is a scalar. We can call it here scalar. This is scalar, and this is the element of the matrix. It's the element of the matrix. So we are going to multiply this scalar into each element in the matrix. So this is going to be now 2 multiplied by A is going to give us 2A. So 2 multiplied by A. This same 2 multiplied by B. And then we multiply again the same 2 by C. And then by D. So we multiply each of these elements by the scalar. So 2 times A is going to give us 2A. And 2 times B is going to give us 2B. 2 times D is going to give us 2C. 2 times D is going to give us 2D. So this is the simplest explanation on a scalar matrix. So the scalar here is the number, or it could be a constant outside the matrix. So we use that constant and multiply the constant into each of the elements of the matrix. So let's take also take note of the sign. Let's say again we are given minus 1 A and D, and then the A element is again A, B, C, D. You always take note of the sign. So now this is going to be now minus 1. We multiply minus 1 into all the elements of the matrix. So this is going to be now minus 1 times A. This is going to give us minus A. Minus 1 times C is going to give us minus C. Minus 1 times B is going to give us minus B minus D. So you take note of the sign, you multiply the sign. Right? So now let's say again, there's another sign here on the B and also sign on C. Remember that minus times minus is plus. So this is going to be now minus A. Minus times minus is plus. So this obviously is going to be plus going to be B, and then minus times minus again. Take note of the sign. It's again going to go C, and then minus times D is minus D. So you always be careful and take note of the signs when dealing with scalar or multiplication in matrix. So this is all on scalar matrix, and I'll be giving an example. So now let's discuss what then is a vector matrix. Remember, we are discussing on the multiplication of a scalar matrix and that of a vector matrix. The method used is the same as multiplying two matrices. A vector matrix is 2 by 1 matrix most of the time. Even though in our previous video we said that before we multiply matrix, they must be of the same order and all that stuff. But the vector matrix kind of go against that law a bit. So the vector matrix, say we all know what a vector is. Let's say we have a vector. Let me just give an example here. Right, let's say we have vector. Let's say x is equals to xy. We know this is a vector. And then we are given matrix A as A, B, C, D. This is vector X and this is matrix A. And then they ask us to find AX. Find AX. Remember that A here is the matrix and then X is the vector. So this, here comes the multiplication of a vector matrix. So we said then this way, what is matrix A? The element there of matrix A, we have A, B, C, D. So this is the element of matrix A, and we also have vectors X, B, X, Y. So this is the vector. So how are we going to multiply this matrix by the vector? So this is matrix, and this is vector, and this is vector. So how are we going to multiply? Remember the law, we say we multiply the column of the matrix by the row of the other matrix. So that law also apply here. This is the first column. This is the first row, AB. So we're going to multiply this first row by each of the elements in the vectors. And let's say this is column. This one is row. So I'm going to multiply it. And we follow the same procedure. So say A times X. We're going to multiply A by X. And then plus with what? We are also going to multiply B by Y. The same procedure, just like we did for the 2 by 2. So this is going to be now A multiplied by X. This one set plus B multiplied by Y. We send another set. So we have dealt with the first row. We go again for the second row. In this case, it is 2 by 1 matrix, of course, because this one, for the vector, we only have one row and one column. And for the matrix, we have 2 and 2 columns. So you can call this 2 by 1 matrix. It's only applicable when multiplying vector with the matrix. So we go again for the second row. The second row again, we are going to multiply again. This is going to be now C, we multiply it by X, and then D, we multiply it by Y. So this is going to be C times X plus D times Y. So the answer now is going to be AX plus BY, and then we have CX plus DY. So this is it. So now let's take a real problem and let's see how it works. Example. Let's say we are given that we have matrix A to be 2, 1, 4, 2y, and y vector to be 3, 1, and this, and A, I'm just forming this question, and AY equals to 7, 8. AY is equals to 7, 8. And then I say find Y. And then we are asked to find Y. So we go solution. So remember, this is the form. So now let's set it. What is A? A is what? 2, 1, 4, and then we have 2y. This matrix A. What is Y? Remember, Y is a vector. The vector is what? 3, 1. And then they say AY equals to what? 7 and 8. So we have set it this way, and then they ask us to find Y. This is what we are going to find, Y. Yeah, we can see already, look at Y. So why are we looking again for Y? Well, that's just the point. So now let's solve for Y. Even though we can see Y, so let's see Y value. Okay, so we go. Remember, we follow again the same procedure. We multiply each row by the vector. This is row 1, and this is what? Row 2. So we first deal with the row 1, first row. So we say 2 multiplied by 3 plus 1 multiplied by 1. So this is going to be 2 multiplied by 3 plus 1 multiplied by 1. And then we're taking it for the second row, row 2. We see what? 4 multiplied by 3 again, and then 2y multiplied by 1. So 4 multiplied by 3 plus 2y multiplied by 1. And all this equals to what? 7, 8. I hope we are flow in. So we proceed. We say what? 2 times 3, it is 6, plus 1 times 1 is 1. 4 times 3 is 12, plus 2y times y times 1. This is going to give me 2y. And all of these must equals to 7, 8. Remember, we are looking for y. So in this case, obviously we take them by the column. So 6 plus 1 is going to give us 7. And then 12 plus 2y, we put it for now this way, because they are not like terms, so we cannot add them or neither subtract them. All of this must equal to 7, 8. So we go again. Remember, this is equals to sign. So meaning this first column must equals to the first column also. And then the second column must equals to the second column. So we go again. We say was 7 equals to 7. And then 12 plus 2y equals to 8. Remember, 7 equals 7. The same as, let's say, we transpose, this is going to be 7 minus 7. So this is going to be 7 minus 7. And what is going to be here? 0. So 7 minus 7 is actually 0. So this is 2 cancel. So this is going to give us now, and this again, if we transpose, remember, we are looking for y. So if we, let me just take this one special. This is 0. What's up then? This one is going to give us 12 plus 2y is equals to 8. Remember, we are looking for y. We are finding the value for y. So if we are looking for the value of y, we transpose the constant. So we are going to transpose 12 to what? To 8, constant to constant. I remember when you're transposing, the sign change. If here is positive, when you are transposing, it becomes negative. If here should have been negative, when you are transposing, it becomes positive. Take note of that. So this is going to give us now what? 2y must equals, remember already 8 is here, and if we are transposing 12, is going to be minus 12. I hope you understand this. So this again continue. 2y is equals to, so 8 minus 12, remember the bigger number carry the sign. So obviously it's minus 4 because 12 is greater and the coefficient of 12 is minus. So 8 minus 12 is 4, but the bigger number carry the sign, so we say minus 4. And remember, we want to know the value for y. So obviously we divide. In order to get y standalone, we divide by 2. We divide by the coefficient of y. And we also divide this one again by 2. So if we divide this by 2, change to itself 1 time, so we are 2 times, we are only left with y is equals to. And then 2 into itself 1 times into 4 is 2 times. What is the sign there? It's minus 2. So obviously y is equals to minus 2. So this is the value for y. So this is all about scalar matrix and a vector matrix. Same problem like this, just follow the same procedure and you'll be good to go. This is very simple with us. And now Scalar, we are here to give you the most simplest form you can solve any complex problem, be it mathematics. And I want you guys to know that we are not only dealing with the teaching aspects. We'll be discussing on real life hack system and discussing on how to things that we see complex, we are going to simplify them. That's why we name the channel and it's simple with us. Everything is going to make simple just with us.